Thank you very much for inviting me to UIC and the Digital Days. I was here last time, 2016, when we had a very interesting digital day here at the UIC. So, dear UIC members, dear railway professionals, and dear ladies and gentlemen, it's a pleasure to be here on the platform Open, Share, Connect, which is the theme for UIC. And I think that's really, really important for the future. Open, Share, Connect. I'm very glad to be here, and I had the opportunity also to participate in the UIC transformation tour to China in September. We had a sort of debriefing afterwards, after the tour to China, to see a little, what have we learned. So we just said one word: amazing. Amazing. We had visits to Alibaba, Tencent. We had visits to Huawei and several other companies. And we were astonished by the things that are happening in China in digitalization. In some areas, we think they're at least 5 or 10 years ahead of us. So now, Europe and the operators really need to get going in a much faster way. Today, I will speak about digitalization as the foundation, and then AI, artificial intelligence, how that works, and some definitions. Most of you are probably aware of things that are happening in your companies, and with rolling stock, for example. It's very important to be really good at predictive maintenance. And now we have the tools to get going. The tools, we look into 2 examples about predictive maintenance. It's for 2 operators in Sweden. You're going to see how they are doing and what they're doing. Now I will get to my first slide. I represent 42 members in Sweden. And it's both freight and passenger traffic. It's some of the associated members as well. We have like Astoc, Bombardier, and some others. We have 42 members, mostly Swedish, but there is also a number of international companies. We have, for example, Transdev, we have MTR, we have Keolis, and so on. And our 3 key words, themes, that's my purpose, is how to improve the quality, capacity, and the competitiveness of railways. These are the key thinking we are. So today I will speak about, as I said, digitalization and AI, predictive maintenance, past, present, future, what is this all about, and then some examples and some lessons learned. When you speak about AI, how many people in here have done something with AI? Couple. How many of you have a definition of AI? A few. So I went out to ask our members, what are you doing in AI? What's happening? Is this just a buzzword, or is it something else happening? And it's like a building. You see, when someone builds a house close by your premises, and you go out and see there tomorrow and the day before, nothing happens. But in 1 year, there's a new house. A lot of things happen. And this is what I think is happening right now. We're just in front of something huge that is coming. I will start with digitalization and predictive maintenance, and AI. And first, digitalization is underway. The maturity varies by industry, but the potential, I think, is just untapped. The efforts to date is mostly sort of digitizing what you have, not looking around the corner. And some organizations are there, and some is still sort of in Jurassic Park mode. You see airlines, you see hotels, car rental, mail courier, parcels, logistic providers, and at the bottom, I put rail and freight forwarders. There's a lot of things to do in our industries. So we're not there yet, but how far have we gone? Are we facing the tipping point of the digital life cycle? what is happening in our industry? Or is this becoming mainstream? Is all of the operators getting on the top list in each country as the main digital examples that everybody's looking at? Not yet. A lot of things to do. Will we get margin compressions? Will we get flow of values to other stakeholders? Will the laggards of the incumbents die? Is there what is the solution here in the future? What are we facing? But of course we are facing a number of disruptions that could fundamentally change the travel and transportation industry. For example, we have the online platforms. It's basically marketplaces. And you know the words, eBay, Amazon, Airbnb, Uber, and so on. Will they make us in the railway business just ordinary capacity providers? We just providing the capacity, and they have the customer relation. They are selling the services and all the things that are associated with rail. Or do we see the expansion of the large tech companies? Do we really have to face the fear of the hungry tech giants that are coming into our field? You know, all the FANGs, the Facebook, LinkedIn, Instagram, Facebook, Twitter, Google, Apple. They have the data already and the cloud, selling the cloud. So can they go into invade our industry? Then you have, for example, advanced robotics. Pointer. Oops. 007. Advanced robotics, for example. AI robots. You have seen the robot Sophia with Elon Musk, but also robots that are taking care of elders. We have robotic tools in manufacturing. There are millions of robots out there today doing the cleaning, painting, machine handling. So it's basically about efficiency and productivity in several industries. And then we have the asset sharing. The sharing economy is nothing new to you all. What is mine is yours. What is mine is yours. It's the collaborative consumption. There again we have the household names of Uber, Airbnb, BlaBlaCar, the people to people business, business to consumer, business to business, or the accessibility thing, the access economy. It unlocks value, reduce the barriers to entry, focus on effectiveness over efficiency, using the spare capacity, and consumer access instead of ownership is the new thing. Then we're looking into autonomous vehicles. You know, these all trucks all trucks traveling with 10 meters distance between each other and reducing energy consumption. It automates logistics. We can see also these things happening slowly in rail, ATO, information sharing, reduced lead times, basically cost efficiency. And then we have additive manufacturing, 3D printing. How many have a 3D printer at home or in office? One? Good. I have one example of a 3D printed tool. Let's put my stuff here. That I got from Deutsche Bahn. A train whistle. 3D printed. They're doing a lot of things now. There's a arrangement between a collaboration between Deutsche Bahn and SJ in Sweden on digitalization, and they are inventing all kind of things now. So it's really fun to see. Every week there's a new thing coming up. So remember, you saw it here. So where are we? What's happening now? We're basically in the local world. We're here, traditional company, Barang, the train operator. We have the value chain logistics. This is what we are doing. Local world, physical assets. But now there is a trend moving up here to the digital world and the global unlimited world. And who is going to be the prime mover? It's about offering design. What things can you put together in the future? Then we will have a reallocation of time and space. Who will be the key actor in the future? We will see, should we be the backbone, as the European Commission say, the backbone of transport, rail in Europe, for example. And could we be the prime owner who reconfigure the business? Or will we be reconfigured? One way of looking at this is if Internet of Things, so we call it Internet of Trains. What type of enabling technologies? IoT is usually a buzzword. And if you look on what IoT stands for, it's basically three things. You have the devices and sensors. You have the cloud and connectivity. And the application and analytics. But how will that work over sectors and industries? If you have the sectors, manufacturing, energy, transport, public, healthcare, if everybody is applying these type of things to their own business, you will have a common denominator across industries. Will that take over? It's what happened in the data sector in the 90s. Only the paranoid survive, if you remember that. And then the final question is, of course, who will earn the money? Who will be in charge of the customer? Who will get the returns? So if you look on different requirements, this basic underlying information and data flow, you have the massive IoT communication, the massive numbers that you need to fill up, but then you have the critical IoT information, the communication with the really that requires reliable and available information. It can't go down. You need to, for example, remote healthcare, traffic safety control, industrial application. It has to work. Mobility as a service is something all you have. Maybe it's like Jean-Pierre said, accessibility as a service. That's the new word. Now we heard mobility as a service, but maybe it's accessibility as a service that is the key. If you don't have access, you can't have mobility as a service. The fastest, cheapest, most comfortable, and most sustainable transport you get access to. And it has to be a provision of sufficient services. You get new and loyal customers by offering this. So who is the prime mover and who designs this offer? So we have data integration platforms that consolidate transport data. And will this be the solution? There's already in use, but will it add more to the business? So what is AI? I spoke about definitions. The definitions are different here in the sector. And I like this definition. I looked at McKinsey and Company, a consulting firm, about how they define it. And they define it as an ability of a machine. The ability of a machine to perform cognitive functions that we associate with the human mind. As perceiving, reasoning, learning, and problem solving. And the most common part of AI is machine learning. I'm sorry. Machine learning to very large data sets, and it's about algorithms that detect patterns, that to make predictions and recommendations by processing a large data set. This is the definitions. If you look on the machine learning, you have different type of analytics. You have descriptive, predictive, or prescriptive. So descriptive is, as you all know, is what happened. Predictive is what will happen. You can find the different data that make a pattern. And then you have the prescriptive, what to do. So this is the focus of machine learning. If you look at the different type of problems that AI focus on, it's the problem types is classifications, estimations, clustering, optimization, anomaly detection, ranking. So all these kind of problem types that you use the algorithms for. But if you look at more closely on combining big data and the complexity of technology and the business impact, you can start at the bottom here with the reporting, monitoring. Reporting is, of course, what happened. And then monitoring, what's happening now. Data mining, why did it happen? That's the machine type. Evaluations, why did it happen? And then what we're talking about, prediction, simulations, what will happen? These are really the key. And then, what type of business is this? Is this worth spending all this money on something new? Everybody has AI initiatives. If you look on the estimates about where is this money coming from, then you see here, it's basically the big price is the supply chain management and manufacturing. Here's where the predictive maintenance have the big, really the big profitable potential. And McKinsey estimates it's about $500 to $700 billion worth of doing this. So I will speak about predictive maintenance as such, because it's such a huge potential. What is that? Well, this is Stockholm, the old town from 1300 something. We have upgraded that with some subway operations as well. So past, present, future. Corrective maintenance. You fix the train when they're broken. The workshop dependent. You have a manual follow-up. Everybody knows this. You fix something and something happens. Then you have the preventive maintenance. Static maintenance plans, manual planning, bulk delivery. You creating spikes in maintenance, affecting the availability. And when we speak about predictive maintenance, we want to predict much better than how this is based on historical data, mean time between failures, how performance and status can develop. We do the what-if analysis, and we try to ensure that we don't have any spikes in the budget. There has to be a common pattern. So combining this is really the predictive maintenance. Corrective maintenance, preventive, predictive, and then you can get, as the crown, the prescriptive maintenance. I see my time is going, but I will go into some operator case here. Here's one operator, international operator based in Sweden. They look on predictive maintenance of components. So they apply machine learning and do scenarios, and look at value over time, and really the purpose is decision making. So they analyze the performance and measurement data. They build a decision tree to what to do and when. And that gives the possibility to predict maintenance of the critical components. So this is their model. They have the data harvest first from different sources, sensors, detectors. They try to master the data management in different ways. They add the domain expertise. Data management, domain expertise. And then they go into data science and business intelligence, looking at the algorithms, models of statistics, machine learning, etc., to get the results, to make the difference through change, and working with change management and agile processes. Another case is SJ, the Swedish incumbent. Their focus is really on functionality, availability, and efficiency. So, starting off, why will they use predictive maintenance? Equipping everything with sensors, that's quite expensive. And you need to handle the data, and decision is also demanding. So any solution must address punctuality, availability, and efficiency. And punctuality is the most important. We have a national initiative from all the operators and the infrastructure manager about reaching 95% punctuality. And how much is that related to vehicles? Less than you think, actually. But we need to increase the reliability. So availability, a train in the depot doesn't make any money. You need to get out there fast. Efficiency, you have to make maintenance more plannable and decrease the life cycle cost. There's other factors as well as traffic safety. So what do we have to work with in regards to predictive maintenance? In SJ, you have the locos, but they don't have so much sensors and any sources of information really. So almost nothing. But then they have X2000, a couple of sensors, and now getting modernized, upgraded, with plenty of opportunities. And SJ also have X40, modern, greater capabilities. And the same goes for X55 fleet. What will the future hold? The previous mainframe solution is called Ford, but is quite old legacy system. Now there are new possibilities with implementing SIP and some other tools. And the Nexala platform is the common base for this. So looking at the depot of the case, if you look at punctuality, availability, and efficiency, this is the main depot outside Stockholm called Hagalund. Where's the money in predictive maintenance? SJ have a lot of assets, and a big number of different systems, and the bogie components are very expensive. So if you look on the bogie components, they have different intervals of maintenance. They have different overhaul intervals, and they decided to focus on the bearings and wheels. And you see they have different intervals. Can you raise that to get better effect? How to overprove the manufacturer that says this is the interval? So, well, you need to monitor the conditions, of course. And it's expensive and troublesome, and that's what SJ did. They said that we really need to improve all of this to the same level, 1.2 million kilometers. And the solution they chosen was to do it on wheels and wheel bearings. So I'll tell you about the wheel bearings. This is one of the major solutions then. What kind of equipment is available to supervise bearings, for example? Well, it's the most advanced solution is you do the sensor approach. You can have detectors as well, but they pick the sensors. There's a lot of technical features mounted to this. It measures then acceleration, temperatures, and so on. And applying algorithms, you can really determine the problem. And the analysis is doing externally by a supplier. SJ gets the information, but the data belongs to SJ. The equipment listens to vibration, the wheel damage, radar height, and they also get the 3 months warning before any breakdown. So they have several kind of sensors. This is one. But how do you make this data useful? We have the component data from the wheels and bearings. And have we saved money now since we have that? Perhaps we are creating new problems instead. You need to look at you have the component condition data, but you have to look at the traffic plan, the workshop, the passenger occupancy. Is there other maintenance to consider? Is there any other problem we create? Can we take the train out of traffic? So it really need to be optimized together. And this is what SJ called the predictive maintenance. So doing this, you need a structure. The first lesson, have a structure. Don't just open the catalog and select the product. It might work, but you can also reduce synergies. And the other is to share data. It benefits your own sake, and it's possible to outsource analysis. And you need to have a system perspective on all this together. You have the purpose, you have the goals, you have the method, you have the process. And this is the future outlook for SJ. And everything from customer to real estate to the software application programs to information systems, infrastructure manager, traffic control, engineering, information models, sensor detectors. This is what they look like. So this is the lessons. Almost finished here. Next slide. So we can see that the fewer disruption in traffic, better decision support when problems occurs, and better analytical capability and lower costs. So the real question, when you ask the members, why do you need this? What is the purpose? What's the lessons learned? It's about how to improve decision making, basically. Very operational. There's no definition of AI yet. Is there a need for standard? Should maybe UIC set a standard? What is the AI standard for rail? There's no clear business case yet. Everybody's testing here and there. It's a moving target. Automatization is the most common area where you look at applying AI. And one of the key things is also to use, it's useful for pattern recognition, classification and predictions. And it's about machine learning and probabilities. And one interesting reflection is that AI does not yet solve new problems. We think that's going to be a solution for everything, new things, and you can just end the situation. But it's really about the existing problems that we try to solve. And how do we fit AI to the right problems? Can we move AI to complex and unsolved existing problems? However, there's a lot of trains that now will be equipped with sensors and data. So there's a huge potential out there. So start going. Think big, start small, act now. Thank you.